Alright, so let's start off with the first one. In one radioactive decay, radium gives rise to radon, as shown in the equation. What particle is also produced? So can you guess for this one? So what you can see is, for the atomic number, we are having a deficit of 2. And for the mass number, we are having a deficit of 4 units. So what particle must be emitted for which the mass number is 4 and the atomic number is 2? Yes, it would be alpha particles. You can write it as this thing, helium, He24. You see, if there were helium, if there were alpha particle, only then you can balance the equation on both sides in terms of their proton number and the mass number. Let's say you write something else. You write the beta particles. You can write electron or beta particle both. Now the atomic number and the atomic mass, they are not same on both sides. On the right side you have 222 plus 0, which is 222, and on the left side you will be having 226. So you can balance the equation only if we place the alpha particle here. So alpha particle is helium. You can write it this way, or you can write with the symbol alpha as well. Both would be fine for paper 2, but here we have to just pick up the right answer. So an alpha particle. Let's move on to the next one. So here we have the next one. GM carried out experiments in which alpha particles were fired at metal foil. Most of them passes through the foil with small deflections, but some of them were deflected at large angles. These results suggest that atom contains clouds of electrons through which some of the alpha particles cannot pass. Okay, but how does this explain this thing? Most of the alpha particles pass through the foil. So this does not give us any information about that sentence. Atom contains neutron that the alpha particles bounce off. Okay, but once again, how does this give us the information about the highlighted part? It does not. Atom contains positive and negative charges spread throughout their volume. Then they should be having plenty of deflections. Not a few, or not some were deflected through large angles, or not small deflections. Then there would be plenty of deflections. So this is not consistent with the statement given in the question. The last one, atoms have small positive charges concentrated in a small volume. Concentrated in a small volume gives you the information about this thing. Now most of the alpha particle pass through the foil because the small positive charge was concentrated in small volume and the rest of the space was free, and that's why most of the alpha particles were able to pass through it. So what happened was, here you have a nucleus of one atom here, nucleus of the other atom here, nucleus of another atom here, and in between you have the electrons and the free space. So most of the alpha particles were able to pass through it because the nucleus is concentrated only in a small space, in a small volume. So D is consistent with everything given in the question. Alright, here we have the first one, question number 38. A nucleus is represented by Z91 to 30. Okay, whatever the element is, we don't need to know the element. We'll just go with the symbol Z, which is a general symbol, not the actual symbol of the element. It emits one alpha particle and then one beta particle. What is the resulting nucleus X? Okay, this one is very interesting one. So you have this thing, whatever the element name is, we represent it by Z. So the atomic number is the atomic number is 91 and the atomic mass is 230. So the thing is, what do we get if there were an alpha decay, if it emits one alpha particle, well, there would be a decrease in the atomic number by 2 units. So instead of 91, it would have been 81. So let's call it element Y. Once it emits the alpha particle, let's call it element Y. Okay, totally your choice, whatever you want to call that, doesn't matter. So the atomic number would be 89, the atomic mass would be 226, because along with the alpha particle, this thing goes away from the element. Decrease in the atomic number by 2, decrease in the atomic mass by 4. Now, what is the element that you're left with? Y, with the atomic number 89 and the mass number 226. So in the next step, a beta particle is also being emitted. And let's say after the beta particle is emitted, our element is now represented by X. So it would be written as X, and you can place the beta particle here. You can write the symbol beta or the symbol for the electron, -1 here, 0 here. So if the beta particle is emitted, what happens to the what happens to the atomic number? It increases by 1, because we have to subtract -1 from 89, and subtracting -1 from 89 would be written like this, which is 90. And from the atomic mass, we have to subtract 0, so it would be written as it is, 226. So what is this atomic mass and the atomic number that we are left with? 90, 226. So for this one, C would be the right answer. So I've broken it down into different steps, but that is just for the explanation. This is just a question of 1 mark. Should be able to do it in your mind, the calculation. So what you do is, you say the atomic number is 91, then you think about it. Once the alpha particle is emitted, the atomic number would be 89. And then you remove a beta particle from there. So you should know that if the beta particle is emitted, the atomic number would increase by 1. So increase 89 by 1 unit, and you get 90. And you only have a single option for which the atomic number is 90, which is the option C. Let's move on to the next one. Here we have number 39. So a nuclide of the element platinum is Pu 94-42. What is the number of neutrons in the nucleus? For finding the number of neutrons, it's very easy. What you can do is you can subtract the atomic number from the atomic mass, and there you get the number of neutrons. So 242 minus 94 should be getting 148. Yeah. So B is the right answer for this one. Okay, let's take a look at the next one. Question number 39. A nuclide of the element platinum is, once again, the same. How many neutrons? Okay, it's just the same question. We're going to skip this one. Question number 40. And keep in your mind the MCQs from this chapter you generally get on the question number 37, 38. Previously, it were like on 38, 39, 40, but now we have the last question from the chapter of space physics, so they would move back by 2-3 places. So question number 36, 37 and 38 are most likely to be from the chapter of nuclear physics. Which statement defines the isotopes? It's a very easy one based on the facts. Isotopes have same mass number, sorry, same atomic number, but different mass number. Okay, same number of protons, that's correct, but different number of electrons, no. Otherwise, your atom is not neutral. It must be neutral. Same number of neutrons, no, not even in discussion. Same number of neutrons, nope. Same number of protons, okay, but different number of neutrons, yes. D is the right answer for question number 40. Okay, let's move on to the next one. Which conclusion can be drawn from the GM alpha particles scattering experiment? A positive charge is spread throughout the atom. No. Positive charge, matter of fact, positive charge is concentrated in a very small portion that we call nucleus. Electrons are arranged in orbits. Okay, they might be arranged in orbits, but the thing is, through this experiment, we found out that most of the alpha particles were able to pass through the gold foil, and some of them were deflected. So that information has nothing to do with this one. Electrons are negatively charged, okay, but once again, the results obtained from the experiment do not give information about this thing. There is a dense nucleus in the atom. Yes, there is a dense nucleus in the atom. You see, option C, option B, and option D. These options are all right, but the problem is, it is only the option D, or it is the information given in the option D, which is obtained through this experiment. The other informations, the other pieces of information, those are not obtained from the experiment. Alright, let's move on to the next one. What occurs in the decay of the radioactive nucleus? Alright. So what occurs in the decay of the radioactive nucleus? The nucleus absorbs another nucleus? No. The nucleus absorbs at least one of the radiation? No. We didn't study anything like that. The nucleus always splits into two equal fragments? No. The nucleus emits at least one form of radiation. That is true. Let's move on to the next one. Question number 39. The radioactive nucleus with the atomic number 37 and the mass number 87 decays with the emission of beta particles. How many protons and neutrons are left in the nucleus? So proton number means the number of the atomic number. So with the beta decay, I'm not going to write down the equation, and you not necessarily need to write down the equation, just save time from there. You know that with the emission of the beta particle, the proton number increases by 1. So instead of 37, it would be now 38. So how many options we have for 38? We are left with option C and D. And the next row represents the number of neutrons. So number of neutrons would be the difference of the atomic mass and the proton number. So you subtract these two, then you get the number of neutrons. So if we subtract these two, we get 49 as the right answer for this one.